Hello everyone, and this is going to be a review of the material and specifically more problems that come from this unit, the Interdependence and Gains from Trade for an economics class. Now, if you've been following me, the first couple of lectures have been more focused on material that isn't really problem or math based, but those days are going to be gone. We're definitely getting into more problems. And let me tell you, when I opened up the test bank for this particular unit, there were 350 plus questions in it. So I looked at it and I swear to you, maybe about 75% had some sort of a math base to it. So gone are basically those nice little easy definition questions. I also have to be honest, if you're not going to get through this test, or any other tests at this point, if you don't have scrap paper and a simple calculator for them, even when you're going along with me in these lectures, you should have some scrap paper and a simple dollar store calculator that adds and subtracts. Because the more that you practice math-based questions, the easier they are. So when you get faced with them, if you've practiced them a few times, hopefully they just won't stump you. And also, while I can't possibly cover all the questions in the test bank, the good news is that the questions do tend to repeat. They just have different names, different graphs, different numbers, but basically the same economic problems. So if you can learn to solve one set, you can probably solve many of the others that are going to be on your exam. So let's get going and take a look at this. This is a quick review of the definitions that come out of this section of the course. You must know the difference between like absolute advantage, opportunity cost, comparative advantage, and one, they'll keep coming up in the course. Also, if you do have non-math questions, they're mostly going to be about that. Now, absolute advantage is when a producer can produce a good or service in greater quantity for the same cost or the same quality at a lower price than the other producers. This can be an individual like LeBron James who plays basketball. It could be a company, some might argue Amazon. It could be a region like the South United States for fried chicken, or a country like Guatemala who has basically got an advantage in growing bananas because of its climates. Now, opportunity cost, we've covered a couple of times by now. If you don't know that it's what you give up in order to produce something else, please make sure you go watch the videos on that or go out to the internet and find a video on it. Opportunity costs are going to be key in basically being able to do the next one, which is a comparative advantage. To be able to figure out who has a comparative advantage, you're going to have to be able to do opportunity costs. So this is basically, looking at the ability to produce some sort of good or service at a lower cost than the trading partner. So basically, if I can do it at a lower cost, whatever that input is, whether it's time, money, raw materials, that means I'm more efficient. I can produce it at a better rate, you might want to say. And then, of course, there's the simple definitions for imports and exports. I'm really not going to do much more about those except for to put them up here. They are part of the unit for this material, but for most people at this point, you know what an import or an export is. So let's move on to something a little bit more important. Remember that in this chapter, it's all about how people and countries gain from trade. Now, this is not an opinion in economics. It is a stated fact. You're probably in the beginning of your economic studies, so you'll be presented with questions that tend to view the world as having very few inputs and that countries and people will trade fairly. Worry about the unfair trade as we get into later economics. Look for many multiple choice questions that are going to be asking you about the advantage of trade. There are a ton of questions like this in the test bank, and they play off these basic premises that you're seeing coming up in the screen. Now, many of them may be situational questions, such as Libby grows flour and Ramon makes cookies, and then some situation where there's a trade has occurred, and you're presented with 4 solutions to choose from. They all tend to relate back to those other aspects that I just showed you as far as the basics of trade. The one thing though is that there is this expectation by now that you know what the production possibility frontier is, the PPF. It could be referred to in either way. If you don't know what it is, please go back and watch that lecture video on it now, because you're going to need to understand that for you to be able to solve the math questions coming up. So as I said, you're going to be presented data, and that data is going to be used over and over again in different types of questions. So here's like a simple little data chart. We've got somebody who's going to be making orange juice. We've got somebody who's making cookies. We've been told a little bit of information, which is, first of all, that they each work 8 hours a day at the same rate, and that normally they work 4 hours on each item, which means they split their day. So sometimes you'll see them say 4 hours per day, or they evenly distribute their work. Either way, it's the same thing. We also know that we discover from this little chart, just to make sure you know, this is hours to make something. So for Ramona, it's going to take her 2 hours to make 1 orange juice, and for Neil, it's going to take 3 hours to make 1 orange juice. He's just a little slower at squeezing those oranges, I guess. But for cookies, Ramona is going to take 1.5 hours, and Neil, he seems to be a pretty fast cookie maker. He's going to be able to make cookies in an hour. So this is the basic information we have. Now, it becomes really important in pretty much everything that you're doing in this chapter that you understand what the basic data is trying to tell you, because you'll need that in order to decide and solve as you go. So let's say they give us a question like, what is production if? Now that means we're going to change something. Something's going to change. So what if Ramona works 6 hours making orange juice and 2 hours on making cookies, and Neil works 3 hours on making orange juice and 5 hours on making cookies? So how do we solve this? Well, first of all, we have to figure out what the normal production of each is if they're working 4 hours per. And then we need to figure out the production of the new hours. So let's first look at basically a chart of how much they made with their normal hours. So this first one, it says 2 right here. So how did I come up with the 2? Well, we know that Ramona takes 2 hours right there to make orange juice, and she's going to be working for 4 hours. So how many can she make in 4 hours? Well, we're going to take 4 and we're going to divide that by however many hours she works, and we know that's going to make 2. So as you can see, the math is pretty simple, but what's going to wind up happening for a lot of students is that they're going to be putting stuff in backwards or upside down or sideways. And a lot of times when I talk to my students, it really is their logic is fine. It's really the math that got them. So how did we get down to 1.5 for Neil right here? Well, again, it's the same thing. It takes him 3 hours to make orange juice, but he's working 4 hours. So what we know is he's going to make at least 1 full one because of that. But if we take and divide 4 divided by 3, you're going to see that equals 1.5. So what we have now in this little chart is basically where they're at right now. So we know what this is, and now we're going to be able to use that as a comparison, because what we need to do is compare it to what their new hours are. Now, as you can see, I like to make these little charts because I just think it helps me keep track of things. So I make another chart, and this time I'm going to work out how much they would make if they're working the different ways. So now Ramona's working 6 hours and on OJ and 2 hours on cookies. So my formula is going to change a little bit. So now it's going to be 6 divided by 2, isn't it? Because we're doing 2 hours it takes to make the orange juice, and she gets to do it for 6 hours. So that means she's going to be able to do 3 now. And so we do the same thing for each one of these items. And we get the second chart. So what the question really is asking us, though, is sort of what is the change going to be, or what difference could we see? Well, we can see several differences if we look at this. So we can answer questions such as, will the new hours produce more or less or the same amount? Well, we know it's going to produce more because we can see right here they were producing a total of 4. I mean, they're producing a total of 4 now. They did produce 3.5, so they're producing more here. They were producing 6 here. Now they're producing 6.5. So they're producing more with this new setup. So this is apparently more efficient for them to do it this way than they did the last way. You know, which is more efficient? The 4 hours of the new, we just said it's going to be the new. And what was the change? Well, we see an increase in productivity of 0.5 for both orange juice and cookies. They both increased their productivity, and the total production rose. You know, would there be an increased productivity? Yes, because here what the argument is that we're working the same 8 hours, but we're making more product. So these numbers up here were for the original 8 hours when we split our time in half. These numbers down here are for 8 hours also, but now we're specializing. Now we're saying we're only going to do this for so much time and do this for so much time. And as we do that, that's going to help us increase. And you're going to see a ton of questions that are going to present you some basic information like this chart, and then ask you questions, multiple choice questions such as this, give you 4 choices, find the right one. So kind of just practice playing with numbers and see if you can figure them out. Best if you can play with numbers where you already know some of the answers, like maybe in your textbook, but that's all these are. They're not as hard as they look. They love to add, though, a lot of extra words just to see if they can confuse you. I want to show you a couple little tricks, hints you might want to say for when you take your test. One of the first things I have always done was draw this little box in the corner of my paper, my scrap paper, or in the corner of the test. Now, the primary reason for this is not that I don't think that you're intelligent, but that in the middle of your test, you tend to get a little nervous, you may forget things, and I'm going to tell you right now, usually the number one reason my students don't do well on a test is generally because they put something in the wrong spot, not because they didn't understand the logic. The logic they've got, but all of a sudden they've forgotten that horizontal, run, and X are all the same thing, or they've forgotten vertical, rise, and Y are all the same thing, or which way a slope is going. By having that quick little diagram that you draw once, and now for me, you're going to see it over and over because I have different slides, but if I draw it once, it's just always sort of there for me, and I can use it. The other thing you have to get really good at is drawing basically these little kind of graphs over here. You're going to be using those all the time. Now, I've said this before and I'll say it again, it is worth investing in some graph paper. Cheap graph paper, doesn't matter. You're going to scratch up on it. Having to draw lines yourself, we get imperfect in drawing lines, and so all of a sudden our 5 and our 4 don't really match up and we wiggle, and then you come up with the wrong numbers. So invest in some cheap graph paper. After all, you're paying for college. I think you can get some graph paper. You could even go to your college library or your computer lab and print out free graph paper if you want to. Now, the other thing that you're going to see me use a lot are basically charts like this. Charts for me seem to make things a little bit easier to know, helps me with my coordinate pairs, make sure that my eye is on the right thing. Not only that, but the labels, in this case X and Y, will help me remember which ones are on the horizontal, which ones are on the vertical. It just really seems to clear things up a lot. And again, it's worth spending the few seconds it takes to draw those out. This is generally my difference between my A student and my C student. It's not that my C student is so bad. My C student quite often didn't bother to take the few seconds it would take to maybe make a chart or something that would help them. And as such, their eye slips or they miss a number and where it goes because they just didn't see it. They tried to do it all in their head. So unless you have some push for time, it is well worth it. So let me give you an example. So let's say, we'll clear off the board, that we have something like this presented to us. And we have a couple of different questions asked of this. But even this information right here, I already know a ton of stuff if I use my simple little charts and graphs. So remember, the first thing I say is that we have to think about what we're actually making. So in this case, when I'm looking at this, I know that we can't have negative production of corn and rice. You can't not produce, I guess. If you don't produce, it's a 0. You're not going to have -1 on rice or corn production at this point. Now, we're not talking about import or export. We're talking about actually just growing in the ground. So knowing that means I already know that I'm not going to be able to go beyond 0 for corn and beyond 0 for rice. So I'm going to make my little XY box here. And I already know my first coordinate pair because they gave us our first coordinate pair. It's right there. So I just fill that into the box. Now, the reason the box, remember, has 3 is that for most cases, we're really looking for the maximum production of one, the maximum production of the other, and a point in the middle. Really, really common. What we also already know from having just this little information is we already know what the slope is. So the US slope for whatever line we're going to draw is going to be 0.4. Now we know this because y over x basically gives us slope, rise over run, and so our y is 2, our x is 5, and so our slope is 0.4. I can do the same thing now for India, and I can get the slope for India, which is going to be a slope of 4. So if you're asked what is the slope, you've already got it. You don't need to calculate anything else. Now one thing that is kind of good to do at this point is to make sure that you plot this out. So remember, I draw my little chart here, and I already know where my first coordinate pair for the US is going to be because I know my 2 coordinate things. Notice I wrote corn over here because we were told corn is on the horizontal line. And yes, I keep the X there. Again, it's just to remind me what I'm doing. And we know that if corn is on one spot, basically rice has got to be on the other. Now, there is a reminder for you, and I see this a lot on the test bank things. For some reason, they like to present information in one of three ways. So make sure that if you have a fraction, like this one right here, that you convert fractions. So sometimes you may see them present your four choices in fraction form. So they may present it in the 2/5 form or the -6/8 form. But almost always they're going to at least simplify that down to 3/4, and sometimes they're going to convert it into a decimal. Remember, all three of those are exactly the same. -6/8, -3/4, and -0.75 are all the same. So if you solve it and at first you don't see your answer, stop for a second, say, wait a minute, do I need to simplify it or do I need to convert this? Or maybe you converted it automatically into a decimal because a lot of us like to convert things into decimals, and maybe you need to go back and convert it into a fraction. Don't freak out that you've got the wrong answer. Make sure first that you haven't missed that spot because the test bank does that a lot. They present it in one of these three ways. Now, once I've got this information, believe it or not, I can actually fill in this entire chart. This is all I need to know. Because one of the things we know is that we're going to have a 0 spot in X and a 0 in Y on both charts. At some point, we're not going to produce any corn. So can I fill in the rest of this chart if I know where my 0 spots are? So remember here, I'm not producing any corn, and over here, the U.S. is not going to produce any rice. So the question would be, what numbers go in the other boxes? And you get this question all the time. Well, this is pretty simple actually, because we already know that the difference between the first two spots is 5. And the nice thing is that the next one has to be the same. So all we have to do is add 5 to 5, and we know that spot is 10. And we're going to do the same thing on the other side. We know that this is a difference of 2, and then the next one is going to be a difference of 2, so that's got to be 4. And I can go ahead and now chart those 2 points over here and draw myself my nice straight line. And remember, this is my PPF, so now I know where my production boundary is for the United States. Well, let's do the same thing for India. By now you've probably already figured out that that's 1, and so the first X has got to be a 2. On the other side, the difference is 4, which means that the difference in there is going to be 8. And again, I'm going to come over to my nice little graph. I'm going to put in my 2 dots. I'm going to draw my little line, and I now know where my production possibility frontier is for India. So look at how much information I have, and all I was given is just a tad bit of information. Now, I may be asked a question like this. If the U.S. shifts to only making corn, what would be the maximum they could make in 1 hour? Well, we know this now. We know it's 10 because we're only making corn. We would have no rice, right? And if we're only making rice, we'd have 4. Sorry, can't get my pen to work. And this would have nothing. So we get a lot of information from such a small amount of information. But using these little boxes like this, it can really help you because these are standard patterns, and those patterns will make it much faster, easier for you to solve your math problems in economics. Let's go back and visit our little simple orange juice cookie one because it's something that I see a lot, as I said, in the database, and you might have other questions. So in this case, we have a slightly different question. So you're asking now to put OJ on the horizontal axis before we had cookies on the horizontal axis, and maybe you would have 3 charts or 4 charts below that would have different lines, different PPF lines, and you would have to figure out which one was the correct one. So how would I do this? Well, first, what they're really doing is sort of asking for the slope. What is the slope of the line? And you have to be able to figure out what the slope of the line is, so at least you can start to pick the right one. Pretty much you can figure out that almost all the slopes in this is going to be down, because right now we're not really looking at any kind of supply. Almost everything they've talked about in this unit is on the demand side, and the demand slope is going to be this downward slope. Generally, this is your demand slope. So pretty much everything is going to be a downward slope. So we know it's going to be a negative number, and we already can figure out what our demand is because we already have a little bit of data points. We've got the data points here, and we've got data points here. So between these data points, we can already begin to figure out, as we did in the other slide, a lot of information. So one of the things we know is my slope for Ramona, because we've got the 1.5 that we saw before, and we've got the 2, but this time because the horizontal is cookies and the horizontal is OJ and the vertical is cookies. So I'm still thinking about this slide before, which is why I tell you it's really easy for you to sort of slip up and just miss, which is why I like to draw everything out. We know that we're going to have basically this as our slope. Now, remember, a lot of times they're going to convert this down into a decimal point. So if you don't see the answer you think you should have, so you don't see this as an answer, convert it into a decimal. Also remember, they're always going to be simplifying their answers pretty much. Anytime I see a fraction, I saw a simplification of that fraction. So we're going to make a quick chart that I showed you how to make before. And we're going to make one for Ramona, and we're going to make one for Neil. And we already know what our first points are because those were given to us, remember? And then we're going to figure out what the difference is between here and here. And it's 2, so it's pretty easy. That means we're going to go 2 here, and we're going to do the same thing going down that way. Because we were given some information so we can do that. But what we're looking for is what is basically the correct chart. You might want to say they would have given you 4. Now we can take these data points that we have and we can make a chart. So we can graph, but we do know it's going to be a negative slope. 1, because we're working with demand, but number 2, remember, if it's a negative, it's got to be a downward slope. So here's a little graph we could quickly make. And what we did is we simply took the numbers for Ramona and Neil. We plugged them in. Ramona is yellow, Neil is green. And you can just draw this, and again, invest in a little graph paper, make a quick draw. Now what you're going to do is look down your choices, your 4 choices, and you're going to find a graph that looks something like this. One where you see Neil is got 1 point on the 2 and the 0, and where Ramona's got 1 at the 0 and the 3. So if you see something like that, then you know, well, that might be one of the close ones, but at least you know what it looks like, easy to spot. But understand, there's a whole variety of questions they can ask you now on this data. So what else could they ask you? Well, they could say, what would Ramona's cookie pre-production be if I produce 4 units of OJ? Well, we already know this because right here we can say I produce 4 units of OJ, and what would my cookie production be? 0. But I already figured that data out. So once I have the data, I can just look at it and answer the next question. Your next question could be, which person has a stronger PPF slope? Well, you can either look at your chart up here, or you can look at your numbers down here. But basically, the person who has the stronger angle, which in this case is Ramona, has the stronger PPF angle. So, could Neil make 3 OJs and 2 cookies? And the answer is going to be no, because if you remember correctly, anything outside your PPF line is impossible to do. We can see over here that the best you can do with making 3 OJs is 1 cookie. If we plot this point, we're going to come up here from the 3, we're going to come over here from the 2, and you would have a point somewhere around here. It's beyond our PPF margin error line, and boom, you can't make it, so the answer would be no, he couldn't do that. He doesn't have the current capacity to do that. Now, what would the total production be if they worked 10 hours each just making cookies? Well, in that case, it's just an extra little piece of information you need, but you'd come up here and you say, okay, this one's making 1.5, this one's making 1, and all you would do is you multiply your hours 10 times, and basically 2.5 cookies, which would equal 25. So if they were making just cookies, that would be our answer for that one. And then, the last question that I have in here is, what would their total production be if they worked 10 hours each, but divided their time equally? So when we say divided equal, that means that we would spend 5 hours on each thing. And so again, you can see how I work that out. There are all kinds of questions in the database that they would simply take this data and ask you, which is why I said it might be worth your time, especially if you see the same data being presented 2 or 3 times, to simply write out these 3, this chart, and maybe make yourself this graph, and you'd be able to answer so many questions. The biggest thing that I see students make mistakes on is that their eyes slip and they see the wrong thing. They don't see horizontal axis, they see vertical axis, or they don't see OJ has changed, or they haven't seen hours have changed. Just take a quick moment to make sure that you're seeing the correct things. So I know I'm going kind of fast, but I think some of this you can go back and review if you need. I want to move on, don't want to make this too long. So coming back to one of the charts, this is sort of a common thing I saw, where you'd be given a data set, you'd be given a question, and you'd be given 4 basic diagrams and you have to select from it. So one of the things you have to look for, of course, is what they're asking for. So this one is specifically saying, let's look at Jamaica. And because they're asking for Jamaica, I always like to say the first thing I want to do is basically cross out Aruba. Aruba is there just to basically distract you, or because it is part of a data set that's going to be used in multiple questions. So now all we're looking at is Jamaica. And what we need to know is how many labor hours are needed to make. One is the information we're given, but they're asking us which is the PPF if Jamaica has 100 labor hours. So I'm kind of talking here to see if you can figure this out. Is it going to be chart A, B, C, or D? Now, I'm going to eliminate a couple of charts for you. Your temptation may be to simply multiply 100 times earrings and 100 times hat. Something that people think to do, well, if I've got 100 production hours, but the problem is if you do that, which would be chart D right here, if you do that, you're wrong, because what we're saying here is this is how many hours are needed to make each one. So we need 4 hours to make an earring and we need 2 hours to make a hat. So if we have 100 labor hours and we multiply it times this, that isn't going to be correct. That would be if we were talking about production. But we're not talking about production, we're talking about labor hours. So it cannot be D. So we're going to eliminate number D. Boom, boom, not you. So then that leaves us basically 3 more choices. Now I want you to notice that with choice A and choice B, one of these you should be able to eliminate pretty quickly because we're looking at where hats are over here. And hats are on our Y. And if we look down here, we have the number 4 for hats. And over here we have the number 2 for hats. Well, I can come over here and say, well, hats are 2. So this is probably not going to be correct because if we're thinking that it's going to be these 2 numbers, well, earrings is on 4, which over here we see earrings are on 4. So I can probably eliminate that one. Now I've done no math, but I've already eliminated half of my choices. So now I'm down to 2 choices, down to B and down to C. Now, you may look at C and go, well, I don't even know how they got 50 and how they got 25 because I don't see those numbers anywhere. But, hate to say it, that's the correct one. So the correct answer is C because what we're talking about is 100 total labor hours. And here it's talking about how many hours it takes to do each one. So this is our total labor hours, and it's going to take us 4 hours per earring. So the most we can make is 25 earrings out of that 100 hours. And for hats, basically it's going to be the other way around. We can make 2 hats in an hour. So we've got 100 hours. We can make 2 hats every hour, which means the most hats we can make is 50. And if we look here, that's on this spot, and that's on this spot. So the correct answer is C. This is why you've got to just be really careful, look at what they're asking for, write things down, just don't make a guess. But there were a couple of them we could eliminate right away just by sort of thinking logically about it for a moment. At least that would give you down to a 50-50 chance. Let's look at a few more. Again, a pretty typical looking data chart that you're going to get or see when you see one of these tests. Notice again, small numbers, like small numbers, but you might still want a basic calculator just to make sure that in the midst of the excitement of a test that you don't mess up your numbers. So here's our question. In this case, we're looking at just Dewey and how much can this person make within 24 hours? Well, first of all, we're going to draw a line through the other one because we don't need it. It's extra information. It's just basically distracting us, or it's using another question. But we are given 2 pieces of information. And again, we have to make sure that we're really careful at what we're seeing. This is labor hours needed to make one of each item. And this is how much they actually can produce in 24 hours. So we're going to work a little bit backwards here because we actually have choices. We already know that one of these is going to be the correct answer. So working backwards, what we want to do is test each one. Now we know we're going to need 6 hours for earrings and 4 hours per hats. And so we're saying basically how many earrings could be made from this? Well, we can make one earring. It takes us 6 hours, so 1 times 6 is 6. And here we can make 8 hats, and we multiply that times 4, which is 32 hats. However, the total number of hats that is, because we're adding these two up, is 38. And in case you don't know, there's only 24 hours in a day, but in case you have forgotten 24, you'll notice that they did give that to you up there in your group of information. So now we're going to test the second one. And so the second one gives us 12 hours, 8 hours, and 20 hours. Well, at least that's within 24 hours. We'll test the next one, 6, 20. Well, now we're at 26 hours. That's too much. And our last one also gives us 26 hours. So there's only one possible choice, which is this one, because this is the only one that has less than 24 hours. So sometimes you just want to work a little bit backwards because they've given you the correct answer. You know the correct answer is in there. But again, we're looking at what we're trying to produce. Now, they've also given you a little extra information here. This information right here, which turns out we didn't really use, did we? Not really. So, you know, you don't have to use all the information that's given to you. Sometimes the information is given on this chart because it's developed for another question. Your key is to make sure you know which pieces of information you might need to solve the problem. Let's move on to another one. Here's another type of question I see a lot. They give you some data, and what they want you to do is tell you about the missing data. Now, it could be what number would be in there and it would make a straight PPF line, and what number might be in there if it's bowed. Now, this is a lot easier than it looks. Let's take a look at it. Now, I'm going to just make this chart bigger because it's a little easier to work with. I want to use that space for something else. Well, they've already given us a lot of information, and we've known before that the numbers are going to be even on each side. So in this case, the space between these are 4. So what space is going to be the other side? Well, we got 6 minus 200, that's 400. That's going to be the middle. And so we know that for a straight line, the number would be 400 because it would plot out. And we're going to plot it out in a minute. But we can double check that our numbers are right, put 400 in there, and look. 200 and 200 evenly divided. So now we know that 400 would be the number to make a straight line. Now, any number that's going to be larger than 400 will make it bowed. But let's double check ourselves. So we're going to basically plot out the 3 points. So we've got our first point right here, 8 and 6. And over here we can see that point right there. And we're going to plot our 16 and 200. I'd always plot that one next because that was given to us. We know that that's correct. Then I'd want to plot out this one, the 12 and the 400. And I've plotted that right here. And then when I drew a straight line through it, boom, I've got my straight line. So my answer to the first question is, you know, what number would be a straight line? I would want to look for the number 400. But now the second question is a little bit... It's not more difficult, but you have to know what the straight line is in order to figure out what a bowed line is. And so one of the things we know is that we need a number that's going to go past 400. So this point might be correct if you had a selection of 12 and 500. Now, here's the key. We know one of the point numbers is going to be 12. It has to be 12. So when you look down your selections and they give you numbers like 12 and let's say 100, well, it's a possibility because there's a 12 in it, but we also know 100 would make it smaller. 100 would bring that dot over here. And now we're not bowing out, and all the bows go out. If we saw something like, let's say 6 and 500 as a choice, well, we know that can't be correct because it's not 6. We know the number we're looking for has to be 12. So we need to look for some sort of answer where that happens so that when we draw that dot and we draw the line, we now have a bow. So as you can see, it's a lot easier than you think, but again, you need to write down a few numbers, plot out a quick chart, and then you'll know if you have the right answer. You're going to see basically a lot of questions, or you could see a lot of questions. Again, don't know exactly what your instructor is going to ask, but when I look at the test bank, I see a lot of questions that have a basic simple chart like this. And there are a gazillion types of questions they can ask you from this. So let's take a look at some of them that, they might be based on a graph. So what does a downward slope tell you? Well, you should know by now that a downward slope tells you that there's a demand curve and that there's going to be a negative slope, basically. That as the demand for one item goes up, so as we have an increase on this side, we're going to have basically a decrease on this side. Why? Because when there's, let's say I have a choice, I might want less bags if I'm buying more shirts. So that's basically what it's telling us, but just be prepared. We've covered this before in other lectures. Now, if this reflects 24 hours of production, how long does it take to make one bag? Well, I've told you it reflects 24 hours of production, and we know that right here, if we're making just bags, because that's what that point would be. Why do we know that? Because that's the line where it crosses the 0, right there. And so we're just going to divide it by 24. It tells us it takes us 1.2 hours to make a bag. Well, they could ask the same thing, which would be basically production on making a shirt. Again, we're coming over here to this point right here, and we're just going to divide it by 24 because they've told us that it's a 24-hour time period. So they might say, okay, this is the first quarter. How many bags did the firm make if they made 300 shirts? Well, now what you want to do is kind of draw your line out to here, and we're going to draw our line going down and see how good I can do at that. Boom. And we can see it's about 10. So that's a pretty good estimate. You don't really have to have a ruler, but a little straight edge may help you kind of keep things in line. Could the CEO set a production goal of 12 bags and 400 shirts if nothing changes in the company? So here's one where they're asking you to basically come out here and say, okay, here's 400 and here's 12 bags. Where do these 2 points meet? They meet right here. That's outside the curve, which means that it's an area that cannot be produced. Again, if you haven't listened to the lecture about the PPF and you don't understand what I just said, go back and listen to that lecture. This is going to be basically information you're going to need for the rest of your economics classes. It takes Kim 2 hours to make a bag. Then her PPF is based on how many hours of work. It would be 10 hours of work because if this was her chart, you might want to say, we know that she can make 20 bags and it's going to take her 2 hours. So it took her 10 hours to make those 20 bags. Oh, it's here. What else could they ask you? I'll hit my click and we'll see what comes up. Okay, sometimes you'll get two graphs that look basically the same, but it'll be slight difference. So they'll be asking you to compare one person to another firm. They may ask you to combine things like how many things did they make all together. So what you really want to do is just make sure that you've got something that can help you make sure you've got some straight edges or a line. Just take your piece of paper, line things up. A corner of a piece of paper works really good to find lines like this. Because if you think about it, that's a quarter of a piece of paper. So I used to take my paper and just put it like that just to make sure, because they don't give you all these nice little hash marks. Hash marks are wonderful if they give them to you, but they don't. So sometimes our eyeballs aren't so good or the print is really little. So you just take your piece of paper and you use it as a corner. Now the other thing you might get is something like this where you are given two. Now these are two actual diagrams that I pulled off of the test bank. Doesn't give you any information about them, but I wanted you to see what they kind of look like, and that's what I meant by they may not give you any hash marks and things. They give you very little. But really a question like this, and one reason I bring this forward, is because basically you want to make sure that you understand that the straight line in B means that there's constant production, where the bow is not constant production in A. So this chart shows constant production. It doesn't matter where we are on this line, the production rate is going to be the same. The slope of the line is the same. The thing is that once you get a curve in your line, and we talked about bowed curves, it means that it is not constant production. So not that you're going to have too many like this right now. You're going to probably see this in later chapters, but it is a possibility they may want to ask you the difference between a bowed line and a straight line, or how would you know that there's constant production? Because it'd be a straight line. How do we know that there isn't constant production because there's a bow. So it's just some bits of information to keep in the back of your head. Let's go on and look at some other stuff. Covered opportunity costs a couple of times, but just a quick reminder, opportunity cost is what it costs you to give something up in order to get something else. So let's say it's Halloween. I've gone through my kid's Halloween bag. I got 12 pieces of candy that he didn't want. But as I'm looking at my 12 pieces of candy, I happen to notice that my mom has got some cake on the counter. And I'm looking at the cake and she says to me, hey, if you want this cake, you give me some candy. And I go, well, what's the cost? So basically she says, yeah, for every 12 pieces of candy you give me, I'll give you 3 pieces of cake. But I don't need 3 pieces. I just need 1 piece. So I have to figure out what is going to be the cost for 1 piece of cake. And that's pretty simple. There's 3 pieces of cake. You divide it by 12, 4 pieces of candy. So the cost for getting the cake is going to be 4 candies. Or if I was going to do some sort of production, in order for me to produce cake, I'd have to give up 4 candies per piece of cake we produce. It's basically the same thing. What you're looking for is basically a number of what it's going to cost you in order to get something else. Then there's absolute advantage questions. And remember, absolute advantage simply is looking at who can make more. Whoever makes more has got the absolute advantage. So in a question like this, we're comparing Larry and Brandon. And so here the important thing is to remember who makes most. So Larry can make 12 candies and Brandon can make 6 candies. Well, that means Larry makes more, so he's got an absolute advantage in making candies. But when it comes to cakes, Larry can only make basically 1 cake and Brandon can make 4 cakes in the hour. So Brandon would have the advantage of making cakes. Now, one of the interesting things about absolute advantage is that one person can have the advantage for both. So in this particular example, we now have Larry making cakes, and Larry can make 12 candies compared to Brandon's 10 candies. Well, again, Larry's making more candies, so Larry has the absolute advantage for making candies. But now he's done something, bought some new equipment. He can make 4 cakes, and something has happened to poor Brandon. He can only make 3 cakes now. Well, again, Larry can make more cakes than Brandon, so now Larry has an absolute advantage for both items. Now, this is kind of, important to understand that while one person can have an absolute advantage in both products, only one person can have a comparative advantage per product. This is a rule, an absolute rule. So when you're looking at a question about absolute advantage, remember, one person can have all the advantages, but when we're doing comparative advantage questions, only one person can have a comparative advantage per product. So really key to make sure you understand which question is being asked about one. Now, the other thing that I have over here, and hopefully you've read it by now, is something I've seen a couple of times or I've talked about a couple of times. But the big thing is just to remember that they are inversed. So if X is going up, Y has got to go down, or vice versa. If Y is going up, then X has got to be going down. And this is going to become important as we begin to solve some of the a little bit more complicated or complex, I prefer to say complex questions. So let's take a look at a couple of those. Pretty common, saw a lot of these in the test bank where they would give you something about an opportunity cost and they would give you some choices and you had to select the right one. So in this case, we're using Cuba, and they make cigars and they make rum, and they've told you here that for each cigar that you don't produce, you're going to get 100 bottles of rum, or for 100 bottles of rum you don't produce, you're going to get a cigar. Well, when I see all these numbers, I don't know about you, but they kind of jolt me around a little bit. So again, I'm going to make myself a quick little chart. I'm going to line them up in columns, makes life a lot easier for me to see them, and I won't lose track. The other thing is I wrote myself a little note. If I lose a cigar, I'm going to gain 100 bottles. I know this. So I've got this little information in front of me. Takes me just a few seconds to write this out. The other thing I have to remember is that we're looking at a negative slope because we're talking about a demand. And remember, the demand slope is the one that goes down over here. And if it goes down, it's got to be inverse. That means is that if there are some numbers going up, there's got to be other numbers going this direction. Well, one of the things I spotted right away when I first looked at this is I looked at this one choice number, I guess it's C. We have 300 and we're going down to 200 cigars. So this one is going down, okay? But then we have 60,000 and it's also going down to 50,000. So this is also going down. But we know that that can't happen because when we talk about demand curves, they have to go in two opposite directions. So I already know that I can basically eliminate this choice because basically bottles have to go in the opposite direction of the cigars. And we'll notice that every other one is, and I'll take some of this extra little detail out of here. You'll notice every other one is doing that. The bottles and the cigars are going in opposite directions. So if we look at this one, we're making 300. Now we're making 200. So that's going down. So that's good. Over here, we've got 60,000 and we're going up to 80,000. So this group is going up. So we notice that. And so we know that that's probably going to be a proper demand curve. And because of that, I don't even have to do any calculations. I could already eliminate basically answer C. Gone. Now we just looked at D, so let's continue looking at D. And so we need to do a little bit of calculations. Well, the first thing we do is we're going to look at the change in cigars. So we have 300. We now have 200. 300 minus 200 is equal to 100. And we know that we're going to gain, remember, 100 bottles for every cigar. So it's going to be 100 times 100. So the difference should be 10,000 basic bottles. Now, here's our thing, though. When we look at this, if we take 60,000 minus 80,000, we got a 20,000 difference. So that's too much. It could only be 10,000, and we've got a 20,000 difference. So guess what? We're going to X that one out too because we know that that can't be possibly correct. So let's move up the list because, hey, you know, I like going in order. As you can tell, I'm kind of that way, but economics tends to be that. So we're going to do the same thing with the next one. We had 200 bottles, 150. That means we're going to have 50 bottles times 100. That's 5,000 bottles. Well, let's look at the difference between 40 and 30. That's 10,000 bottles. That can't be true either because it doesn't match. Remember that our production has got to match, and this doesn't match. So guess what? We're going to draw basically a line through this. Choice B also, it's out of there, which means the only choice is A, but you can just go with it if you want. Me, I want to double check myself to make sure I haven't done any math wrong. So let's look at this one. 200 minus 150 times 50, that's 5,000. 30 minus 35, it's 5,000. Ah, ding, ding, ding. We've got a matching answer right here. So we know which one the answer is going to be. It's going to be A. So again, the actual process of solving it is not so hard. It's really thinking through how would I solve it? How would I find that out? And for this one, it's about basically opportunity costs. And so the big key right here is this opportunity cost. And to remember that you're on downward. And so they have to be inverse. And I am not joking that on several of the questions, you could eliminate one right away because they don't have inverse data. They have data that looks like number C quite often. So you can get rid of that one. Let's go look at a little bit more complicated one. There's going to be perhaps questions where you're going to be given one piece of data and yet you're going to see several questions off that piece of data. And again, if I'm looking at the test bank, they also use this one piece of data and they make 6 or 7 questions around that piece of data. So let's look at some of the things that you might see. So I've given you some data right here. We got 8 hours, we got Eve making cupcakes, we got Maria making cupcakes and brownies. And so what kind of questions could they ask you off of something simple like this? Now don't forget, they're going to throw in a bunch of other stuff that you generally don't need to know, like, oh, I don't know, they're making them at restaurants, or it was cold outside, or they had 1,000 customers today. You know, those things don't actually apply to the answer that they're looking for. So one of the first things they may ask you is, you know, what is the opportunity cost for cupcakes for each? Remember, an opportunity cost, to figure it out, we simply divide what is given up by what is gained. So in this case, they're saying is we want to make cupcakes. So what would we give up to make cupcakes? Well, we would give up brownies. So for Eve, we have 8 brownies we would give up, and we divide that by the 4 brownies that we have. And so 4 cupcakes, sorry. So what would produce is 2 brownies. So what we're basically saying here is that if Eve wants to add cupcakes, for every cupcake she wants to add, she's going to have to give up making 2 brownies. For Maria, basically it's the same thing, but she would have to give up 1.6 brownies for every cupcake that she increased. They may ask it the other way around. What opportunity cost the brownies? And so in this case, what we are doing is what we're giving up is cupcakes, and we're dividing that by what we gained, which is going to be brownies. So for every brownie that we add, Eve has to give up a half a cupcake. I don't know how you give up a half a cupcake, but that is what it would be. You also may notice that I have 0.5 and then in parentheses I have a half. Again, this is just to remind you that they see this all the time on the test bank, that sometimes they'll use the decimal, sometimes they'll use the fraction. So you've got to be able to convert back and forth, because if we look at Maria, Maria has a 0.625 that she would give up in cupcakes for every brownie she'd produce. Now 6.25 is the same as 5/8. So, practice your conversion if you need to. Going from the fraction down to the decimal is pretty easy, but most of the time we're calculating in decimals. And the other thing, remember, they always simplify. So if the answer had been 2/4, they would present it as 1/2. So if you're pretty confident in the numbers that you produce, double check that you haven't forgotten to simplify, or that you need to basically relook at what the fraction or the decimal would be. So these are 2 pretty common questions asked. The big thing with opportunity costs is divide what you're giving up by what you've gained. It's usually the problem is the students just do it the wrong direction around. What about absolute advantage? Who would have absolute advantages in the cupcakes and who would have it for producing brownies? Well, we have to remember absolute advantage is the person who makes the most. So in this case, when we look back at the original data, Maria is the one who makes the most cupcakes and the most brownies. So she has the absolute advantage in both of these. You can have absolute advantage in all products. But the thing to remember is that while you may have absolute advantage in both products, you cannot have comparative advantage in both products. So I introduced that back in the beginning of this, but we'll sort of talk about it as we go, because of course they could ask what is the comparative advantage for cupcakes and who has the comparative advantage for brownies. So let's just kind of look at that. If we put this table together, we're going to be able to determine this. Now here's the nice thing is that you don't really have to calculate anything else, because to be honest, you've already done that here. And you'll notice it's just the same material here, but put into sort of a chart format. Putting it into a chart makes it just a little easier for us to compare them, because we have to figure out who's got the comparative advantage. The person who's going to have the comparative advantage is going to be the person who has the least opportunity cost per item. So in this case, the items are going down in the columns. So this is the cupcakes column, and this is the brownies column. And so we're looking for the person who has basically the least opportunity cost. So who is that? Well, for Maria, she can produce more cupcakes in the same amount of time as Eve. So Maria has the competitive advantage, and we can see that here. She has 1.6 for brownies, which is smaller than the 2 up here. Basically what we're saying is that she's going to be giving up less items or less time or whatever the input is needed to produce the cupcakes versus Eve. And then you can guess that if Maria is good at making cupcakes, Eve is going to be better at making the brownies, because you also notice right away that she does 0.5 where she does 6.25. So you can think of it this way, that basically for Maria, it's going to cost her more to produce brownies than it's going to cost her to make cupcakes. And that's the best way to look at it. We can answer this now. Maria is going to be for cupcakes because she has the lower opportunity cost, and Eve is going to be the winner for brownies because she has the lower opportunity cost. Let's get to some other questions, and we're going to apply this when we get to the last question where we have to combine a bunch of stuff. The other thing I saw a lot of is giving you two charts like this. Now these are actual charts that come from the test bank. I've changed the names to protect this in a little bit, but they'll ask you a series of questions on this. Now I'm going to go into all the data crunching on this one because we just data crunched on the last one, but I want to show you the type of questions you might face, and you can practice a little bit. So what should firm A specialize in? There's no question they should specialize in hats. How do we know this? Because they're basically making 6 hats versus 4 cups if they're only making hats or only making cups, so they're better at making hats. What would firm A specialize in? Well, they'd specialize in cups because they're making 10 cups if they only make cups versus making 8 hats if they only made hats. What is the opportunity cost for each firm for hats? We know that information because they give us the information. Now, the thing that I'm trying to show you here is that while this is the data that you're pulling off the chart from over here, boom and boom, the thing is the answer would be this because we reduced. So just make sure you reduce. I've seen students again all the time miss questions because they forget to reduce or they say they can't figure out what the answer is, and they had the answer. What is the opportunity cost now for cups? Same thing. And by the way, notice that for firm B, I didn't reduce. It says 4/6, and that should really be 2/3. Firm B has the absolute value in what? Well, nothing, because basically A produces more than both of the things that they produce. Firm A has a competitive advantage in what? And firm B in what? So firm A in cups, firm B in hats, and again, if you don't know how to do that, just go back a slide where I showed you how to do it. You have all the numbers in front of you. Now, here's one where you have to be, I started to run out of room a little bit. So what you'd be given is basically all this information up to about here. So the question would really be right here. And I'm drawing through it, so it's a little bit harder to see. What's after it is the stuff that you would figure out yourself. So you would know that firm A is now making 5 cups and firm B is making 2 cups at this time. But what they're asking you is that if the company who could make the most cups, who had the competitive advantage, which you already figured out from the question before, what happens if they only made cups? Now, we know that firm A has the advantage of making cups, and they can make 10 cups. So the overall increase would be 3 cups. Why? Because we've been making a total of 7 cups. Why? We know this because we got 2 and 7 here. 2 and 5 make 7. And so if we've got firm A making cups, and they're going to make 10 cups, because you see, they can make 10 cups if they only make cups. And so we've got a little difference of 10 minus 7. So the increase in overall production would be 3. Now, again, they're going to give you some of this information, but they may not give you all the information, so you have to kind of look it up on the charts. What they'd probably do is make sure that they gave you this information, and if they didn't give you this information directly, what they might do is draw it as a dot, sort of like right here. And firm B would be making 2, so they would have a dot right about here. And they may say, based on these dots, well, you would see, oh, well, currently they're making 2, and currently they're making 5, and 2 and 5 is 7. Same thing, just look for the dots. So this is an example, again, what you might see based on a chart or a graph form as far as a test question is concerned, rather than sort of in that table format that we just saw. Let's move on to some more. I want to give you a second to go ahead and read this problem. I'm hoping you don't get one like this on your test, not because it's impossible to do. It's very possible to do, but it's a little like long division. You can do it, but it's a little annoying because it takes a long time, especially when they won't let you use a calculator and you have to handwrite everything and make all your little lines exactly in the right place, or you misalign something and you get it wrong and then you get all pissed. So think of it sort of the same way. This is just going to be a lot of steps, got to have them all lined up, and you'll get to the right answer pretty easily. What we're really doing is combining all the things you've learned. So the first thing you've got to do is lay out all the information you know. And most of the time, it's easier if you combine things that go together. So what they could produce versus what they are producing and consuming. But this is all information that we got from the actual write-up up there, the actual problem. One of the things they did not tell us, though, is our labor. And we do need to know this as we go on. Now, I'm pointing this out to you because I see students every once in a while simply say, well, I'm going to take 20 workers, I'm going to multiply it by 10 because that's our production, and that would tell us what we're producing or consuming. Well, that would be correct if we didn't already know what they were producing or consuming, because hopefully right now in your little head you said, but wait a minute, if we took 20, we multiplied it by 10, that was going to be 200, and we're not producing and consuming at 200. We're producing and consuming at 100, which means that labor is not a one-to-one ratio, meaning is that it's not 1 unit of labor for 1 product. In fact, what we can figure out, and you're probably decent enough at math to figure this out, is that if there is 200 units that we're producing and we have 20 workers, that basically it's going to take 2 units of workers per item to produce. So 1 for every item, or for 1 per item, there's going to be 2 labors. This will become important as we get toward the end of the problem. Now, there's another interesting thing that they did not do. They apparently in Brazil are not consuming coffee. I don't know how they do that. They must have something else to get caffeine in their body. But anyway, can we figure out the unit of labor? Well, sure, because we do know this one. And we can pretty much see that if we multiply 10 workers times 5, this time we are going to get 50. And so we kind of know that there's a 1 unit of labor is going to be used per 1 item. And up here, you'll notice that the unit of labors are the same for each one. So down here, we're going to see the same unit of labor per each product. So we've got 1 per over here, we're going to have 1 per over here. A little step that sometimes students forget to do, or they don't do it correctly, and boom, they're already kind of messed up, you might want to say, right from the beginning. Now, once we know that, this unit of information, one of the things we're going to need to know is the totals. Why? Because we've asked for their yearly totals. They told us they want yearly output. So how is the yearly output going to change? So that's really not hard to do. No coffee over here, so we're only making 20. We combine these, we make 150. Makes really easy. Next thing, we go back into our problem and we see they're looking for who's got what comparative advantage. So we're going to have to calculate comparative advantage, which means we need to calculate opportunity costs. So opportunity costs, remember, it's basically divide what you're giving up by what you've gained. And so we've got Canada, we've got Brazil. We're going to look at wheat first. And basically, if Canada wants to produce wheat, it's going to have to give up 2 coffees because it's going to produce only wheat. And so there we go, 2 coffees. And what is it going to gain? It would gain 10 because we've got 10 over here. Let me erase these because it kind of covers up all the little words. And we see then that they would give up 0.2 coffees, for this. Did the same thing on each one of these. We've covered opportunity costs before. So basically we know that Canada is better at producing wheat and Brazil is better at producing coffee. And again, how do we know that? Because we want to look at the person who has the least opportunity costs in each category. So 0.2 is far less than 3. And over here, 0.33 is far less than 5. So we know that Canada is going to be better at producing wheat, and we know that Brazil is going to be better at producing coffee. It's all about the person who has the lowest opportunity costs, because if you have a low opportunity cost, that means that you're very effective in what you produce. From there, we're going to make one more table, and then we're sort of done. Basically, we're going to now do a calculation table of what we could produce if we are only producing our comparative advantage products. So we know that Canada is going to pick wheat because that's what they're good at. Now, how did I get the 20 wheat? Sometimes people would ask. Well, we know they're already producing 10 wheat, but they're going to get some wheat because they're not going to be producing coffee anymore. How do we know how much wheat they're going to get? Because it says so right here. It's a ratio. So for every 2 coffees, we get 10 wheats, and 10 plus 10 equals 20. And so we did the same thing with Brazil. And with Brazil, we've got, I'll use a different color, we got 15 here. We're going to pick up 15, and so that leads us to 30. Now, the other thing that you need to make sure that you get straight is what you're multiplying by. You need to know your production and your labor. Now, the labor was determined back up here. Remember, we know that over here in Brazil that every worker is going to be equal to 1 item, so you're going to have your 10 labors. That's why I call it labor, unit of labor, not workers. But over here, 20 workers, no, we may have 20 workers, but we need 2 workers per item. So we need 2 units of labor per item. So we're only going to have 10 labors down here. And we remember that back from over here. We're going to do some quick multiplication, and we come out with a few interesting things. Now, this one is pretty easy to figure out. And you can see that we have produced 200 things by having the specialty do it. And we're going to take away what we're already producing, which you know from here. And that's where we got the number 50 from. Most of you can see that pretty easily. But some of you may be wondering, how did I get the 130 number? In fact, what you may be wondering is, where did the 170 come from? Because you can figure out where the 300 came from. That was a pretty easy figure. Yeah, keeping you in suspense. No, actually, I'm just trying to change my little buttons over here. How did we get the 170? Well, what's important to remember is that while Brazil is not producing coffee, it could have produced at the 150 level. How do we know it's 150? Well, because it could have produced 15. And remember, our workers is equal to our labor, so 10 times 15 would be 150. And if we had added 150 over here, we would have 170. And so just like we had for wheat, we'd have that. And so that's where the 130 is. So this would be the answer to the problem. You would be looking for, out of those different choices they give you, you'd be looking for the answer that would say that we would see an increase of 50 units of wheat, and we would see an increase of 130 units of coffee. Now, as I said, the problem isn't so much hard as much as it's just step by step, and you have to do each step and you have to line it all up, or somewhere along the line you're going to put something down wrong. So I hope this helped you. We'll take a look at some other things as we move forward. As you move through the material for this chapter, a lot of what they're trying to get you to do here is to set you up for understanding supply and demand, which is going to come up basically next for most of you. What this really is doing is beginning to introduce you to some word problems and to introduce you to the use of concepts. I hope this helped. As I said, there's a lot of questions coming from this chapter on the test bank. Hopefully your instructor doesn't just throw the whole test bank out there and say, randomly pick 25 questions from the test bank. But if they do, what you really want to do is make sure that there is a good working order or a good logic in how you put your stuff together. If you go back to some of the basics that I showed you at the beginning of this particular lecture, then it's going to really help you get through each word problem. And they're going to be word problems. And if you're like me, I'm not real fond of word problems. Give me the picture problems, give me the charts, give me the graphs, give me the diagrams, and I am happy. And that last one that has lots of writing in it, half the time I'm asleep before I get to the end of the actual word problem. But believe me, you can do this. It is something that is very doable. So till we meet again online, keep learning.